Hey everyone, and welcome. Today, we're going to dive into a couple of Go's, well, secret weapons, really, maps and formatted printing. Getting a handle on these isn't just about making your code work, it's about writing code that's solid, super clear, and way easier to debug. So let's get right into it. No matter what language you're coding in, you always hit this same basic problem. You've got these different bits of information, and they belong together. So how do you actually connect them in a way that's clean and makes sense? Think about it like this. Maybe you have a key, like the text EST for a time zone, and that needs to point to a specific value, like its offset of negative 18,000 seconds. This simple idea, this key-value relationship, is literally the foundation for so much of what we build. So, what's Go's answer to this? Well, it's an elegant and really powerful thing that's built right into the language. It's called the map, and it's Go's go-to solution for managing these key value pairs. All right, so what exactly is a map? At its core, it's just a way to link keys to values. The keys have to be something Go can compare, like a string or a number, but the values? The values can be anything at all. And the best part is, maps are a fundamental part of Go, not some extra library you have to go find and import. They're just there, ready to use. Okay, let's look at a real example that we're going to stick with for this whole explainer. Here we've got our time zone map. We're mapping string keys like UTC and EST to their integer values, which are the offsets in seconds. The syntax is super clean, right? You can just declare it and fill it with data all at once. Now, maps look super straightforward, right? But there's this one little trap, this subtle thing that gets a lot of people. It's called the zero value problem, and really understanding it is the key to writing code that doesn't have mysterious bugs. And this is where it gets tricky. If you try to look up a key in our map that just isn't there, Go doesn't crash or throw an error. It just gives you back the zero value for whatever type the value is. For an integer, that value is 0. But wait a second, UTC is in our map, and its value is actually 0. So how in the world are you supposed to know if you got a real 0 or if you got a 0 because the key was missing? And this really cuts to the core of it. As the saying from the Go team goes, you need to distinguish a missing entry from a 0 value. If you want your program to be correct, you just can't be guessing. But don't worry, Go has this really beautiful idiomatic solution for it. On the left, you see the lookup that causes all the problems. But on the right, that's the comma OK idiom. When you ask for a key this way, you get two things back. First, the value, and second, a Boolean. We usually call it OK, that tells you flat out, true if the key was there, false if it wasn't. Just like that, the ambiguity is gone. This right here is the idiomatic Go way to do it. All right, let's switch gears a bit to our next secret weapon. Now that we have our data neatly stored in a map, how do we actually look at it? How can we print it out in a way that helps us understand what's really going on inside our program? The answer to all of this is Go's built-in FMT package. Now, if you've ever used something like printf in C or other languages, it's going to feel pretty familiar. But as you're about to see, Go takes it to a completely different level. And the real magic of the FMT package comes down to understanding what are called format verbs. These are those little commands that start with a percent sign, and they tell the print function exactly how you want your data to look. So let's run through these real quick. %v just gives you a good default value. %+v is awesome for structs because it adds the field names. %#v, well, that one's kind of magic. It prints out a full valid Go syntax representation of the variable. And finally, %t just tells you the type of the variable. Getting these down is a game changer for debugging. But I gotta tell you, v is the one you're really gonna love. It's like a superpower. Imagine you've got some complex variable, like our big time zone map. This verb will print the entire thing out in perfect Go syntax. You can literally copy the output from your console and paste it right back into your code. It's an absolutely incredible tool. Okay, so that's great for built-in types, but what about your own custom types? Well, Go doesn't just stick you with the defaults. It gives you a super simple and powerful way to take control of how your own types get printed out as strings. And check out how simple this is. All you do is define a method on your type with this exact name and signature, string, string. That's it. Once you do that, anytime the FMT package needs to print one of your objects, it will automatically find and call your custom string method. It's an interface called the stringer, and it is just so elegant. Okay, but here's the gotcha. There is one big trap you can fall into when you do this. Take a look at this code. Inside our string method, we're calling fmt.sprintf and passing the object itself, m, to the percent verb. So what does fmt do? It says, okay, I need to print m as a string, so it calls its string method, which calls sprintf, which then calls the string method again, and you're stuck in an infinite loop. The fix, though, is thankfully just as easy as the mistake. All you have to do is convert your variable back to its underlying basic type before you pass it into the print function. So here, we just convert m to a plain string. Now, that basic string doesn't have our custom method, so the recursion is broken. It's a really clean and simple fix. All right, before we wrap up, I've got one more bonus tip for you. It's a really cool piece of Go syntax. It's not about printing, but it's something you'll definitely need when you're working with collections of data, especially slices. So imagine you've got two slices, x and y, and you want to tack all the items from y onto the end of x. If you try to do what's on the left, just pass the whole slice y, you'll actually get a compiler error. The fix is that little three-dot operator. Some people call it the splat operator. That syntax tells Go, hey, don't give it the slice itself. Unpack it and pass all the elements inside it as separate arguments. It's so useful for functions like append. All right, so let's recap everything we just covered. We've seen how to use maps to organize key value data and how to use the comma OK idiom to dodge those tricky zero-value bugs. We've unlocked the power of the FMT verbs for debugging and the stringer interface for making our own types look great. And we've learned how to use ... to combine slices. These are the tools that really let you write solid, professional Go code. Look, these aren't just some theoretical concepts. These are the tools Go developers use every single day to build and debug things with confidence. So now that you've got them in your toolbox, the only question left is, what problem are you going to go solve first?